Right now, this planet is losing about 47 trillion watts of heat through its surface, continuously, everywhere. And a body Earth's size, cooling since it formed with nothing topping it up, should have shed that heat long ago and gone cold and solid. It hasn't. Under your feet, right now, the interior is still molten. Heat that, by the numbers, shouldn't still be there to lose. The obvious answer is leftover heat. Earth formed violently, out of colliding, accreting material, and all of that impact energy had to go somewhere. It became heat, and a young molten planet has simply been cooling off ever since. That is not a naive idea. For most of the history of geology, it was the answer, and it was in careful hands. In 1862, Lord Kelvin, one of the finest physicists of his century, worked out how long a molten sphere Earth's size would take to cool to its present state. The mathematics was heat conduction, rigorous and correct, applied by someone who knew exactly what he was doing. The reasoning wasn't the problem. The number was. Kelvin's calculation gave an age of a few tens of millions of years, but geologists reading rock strata and biologists reckoning the pace evolution requires needed a planet hundreds of times older. And when radiometric dating finally arrived, it fixed Earth's age at 4.5 billion years. The physics of cooling wasn't wrong. It was missing something nobody in 1862 had any way of knowing existed. Whatever the real explanation is, it has to satisfy something measurable, and it starts with the flow itself, driving every volcano, every earthquake, the slow churn that moves continents. Not modeled, measured from thousands of borehole readings drilled into land, and temperature gradients taken through sediment on the ocean floor. That gives a firm, well-constrained number for how much heat is actually leaving the surface, and any answer has to reach it exactly. It also has to match what the mantle is actually made of. Volcanic rock carries material up from deep inside the planet, and meteorites formed out of the same original solar material as Earth itself hold a piece of either, and you're holding a sample of the same ingredients the planet's interior is built from. Both contain measurable amounts of uranium, thorium, and potassium, elements with the convenient property of being radioactive, with half-lives roughly the age of the planet itself. And it has to fit the interior's actual state, how hot it really is, how much of it is really molten. That comes from how seismic waves travel through the deep Earth, and from laboratory work on rock crushed to matching pressure. And together, they limit how much leftover formation heat could plausibly still be sitting down there. Add the three together honestly, and they don't balance. The planet is shedding more heat than a passively cooling body of its age, size, and composition should still have left to give. No adjustment to leftover heat closes that gap. Passive cooling of any kind falls short. The missing source isn't in how hot the Earth started. It's in the chemistry of the rock itself, happening right now. Uranium, thorium, and potassium are radioactive, which means their nuclei are unstable and constantly breaking down. And every single time one breaks down, it releases a small burst of energy as heat. Spread that through the entire volume of the mantle and crust in the quantities the rock actually contains, and it adds up to something enormous, not stored from billions of years ago, generated continuously today. Check it against what the answer had to satisfy. It accounts for the measured flow because primordial cooling plus this steady radioactive contribution together reach the observed 47 trillion watts. It matches the mantle's composition because the uranium, thorium, and potassium found in mantle rock and in meteorites are exactly the isotopes, in exactly the quantities this requires. And it fits the interior's actual state because it needs nothing hotter and nothing more molten than seismology already shows. The confirmation is the striking part. Radioactive decay in the mantle releases particles called antineutrinos, which pass through the entire Earth, through you, through everything, almost completely unimpeded. Detectors built deep underground, shielded from every other source of interference, have caught a vanishing few of them coming up out of the ground, and measured their energies precisely enough to identify exactly which elements produced them. Pinning down the exact split between old heat and new heat is still active work. But that a planet is generating a large share of its own heat output right now is no longer in question, confirmed from a laboratory sitting in a mine. The heat keeping Earth's mantle in motion, then, is part fossil warmth from its violent birth, and part an active radioactive engine that is still running and burning down. That ongoing heat drives mantle convection. Convection drives plate tectonics, and plate tectonics recycles carbon between the crust and the atmosphere. One of the reasons, geologists think, that Earth's climate has stayed survivable across billions of years. Mars was built from similar starting material, but it is thought to have never had the bulk to hold on to either kind of heat. It cooled faster, and its engine is believed to have stopped, leaving it geologically dead for a very long time. The ground under your feet is warm and active and able to support life over the long run, specifically because this planet was large enough to keep its radioactive fuel supply burning. The same 47 trillion watts from the beginning, still flowing, still running on a clock that will one day end. There is something worth sitting with here. Nobody worked out the Earth's inner life by looking at it directly. Nobody ever will. It came from noticing that an equation didn't balance and refusing to let that go until it did. That is close to the only way anything about something this large and this deeply hidden is ever known. It is enough for now to know that most of the ground beneath you is quietly, generously still at work. This is one planet's answer to a simple question. How does a world stay warm? Asked of other worlds, the same question has other answers, some already found, some still being worked out. That is where this dot keeps looking next.